Morning, guys. So just going to continue from our lesson from yesterday. Going to make sure that hopefully we understood factoring by grouping and how to factor the sum or the difference of cubes, okay? In addition to the video today that I'll ask you to watch, I'll also ask you to do the back page of yesterday's assignment, which was just a review of functions, okay? So if you hear something in the background, it is Hungry Hippos being played. Sure, everybody is familiar with that game. So on this first set of factoring by grouping, let's first go over numbers 4 and 6. Okay. So again, the directions are going to say to factor completely, and as soon as you see 4 terms, that's when you know, all right, this is when I should try this method of grouping, right? Our normal traditional way of factoring wouldn't work here. You know, the 2 sets of parentheses, factors are the first. That's not what you do here. Right, with grouping, we said we're going to divide them in half, right? We're going to look at the first 2 terms and ask ourselves, what is a GCF of just these 2? And it would be 3n squared. And we ask ourselves, all right, well, what's left? And it would be 4n, right? Not 0. There's always a placeholder. That placeholder is 1, so it's 4n minus 1. Okay? And just redistribute that back in to check your work. In the next set of parentheses, the next set of terms, 4n minus 1, you might say, well, there's nothing common here, right? There's no variable that's in both. There's no number that's in both. But in fact, there is, right? There always is a common factor of a 1. All right, so we saw a problem yesterday that we did the same thing. So we're going to take out a positive 1, which would leave us with 4n minus 1. We also talked yesterday about if this term right here is positive, so will this term, right? They'll be the same sign. Now, because our parentheses here were the same, we can continue to the next step, which would be to group the terms that are on the outside of the parentheses, and then to rewrite the common parenthesis just one time. And that's our answer. All right, let's try number 6. So again, look at the first 2 terms, 14 and 21. All right, well, a 7 goes into both of them, and b squared would be common. So that would leave us with 2b plus 3. All right. Here we could take out a 3 would be common. And again, we would be left with 2b plus 3. Okay. Now look, like I said yesterday, if these parentheses for whatever reason were different, that could happen. And that just means that this problem would not be factorable by grouping. All right. But again, we're showing that it is because these are in fact the same. So not distribute, but group, right? Group the terms that are on the outsides together and rewrite that common parenthesis just one time. All right. So continuing now away from grouping, but doing another sort of factoring. And we said yesterday that, these have a formula, right? They have a setup for you to follow. Okay. And what determines that setup, even though it's not like you have to really memorize 2 completely different things, right? The setup is the same. It's just one's for sum, one's for difference. So the signs might change a little bit. All right. So let's see here. Let's look at, I guess, depending on the class, right, we might have done a problem different than another class. But I'll do numbers 11 and 12. All right. So again, when you see the sum of cubes, we want to try to remember this setup. And A and B are just like, symbols. They're just things that we use to kind of show the setup. They could have been different variables, whatever the case is, but just think of them as the cube root of each one of these two terms. So the cube root of this, the cube root of that. All right, if we can get that first parenthesis set up, I'm pretty confident we should be able to get the rest. So it's going to be 2a plus 5, because 2a is the cube root of 8a cubed, and 5 cubed is 125. Now, we square the first term, so we square a. All right, what I mean by a isn't this variable. I mean, it's this term here. Don't forget, it's not just the variable squared. You have to square the 2 as well. That was a common mistake I saw yesterday, as is the case every year. So that wasn't unusual. Then we multiply the 2 together, and then we square b, or just square the second term. So I kind of like to think of it as like first term, second term, right? Square the first term, multiply the 2 together, square the second term. And that's your answer. All right. So as you were leaving class yesterday, I tried to give you a little clue as I assigned number 12. I said, look, anytime that first term is negative, we always want to kind of factor that out. So I would take the 27 and I would make it a positive, and I would also make this a negative. Okay. I just think it's easier when the first term is positive. So in number 9 and number 12, I think that would be my first step. This setup is going to be very similar, except a couple of the signs change. It's now the difference. All right, so that would be our setup. Now, I know we usually see this term first and then the 27, but no big deal. Okay, I guess we could have moved some things around if we wanted to, but we could just factor it this way. Oh, all right, Liv. All right, Dad's got to finish working. Okay, so we got the cube root of 27 is 3, and the cube root of 64a cubed would be 4a. So again, it's going to look a little different than the other problems we did yesterday, but no big deal. Just continue following the setup. Square the first term. All right. Multiply the 2 together. And square the second term. And that would be your answer. So if I wanted to, check my work and just see what I started with, I would multiply these out, distribute the 3, distribute the negative 4a, and then finally at the end, distribute this negative, and we would get this. All right. So I would like you to make sure you got those answers, last night, in addition to some others that I asked you to do. And then we're going to just kind of circle back and do a little of this as a review. Now, in talking to some of you who have recently taken the SAT or might be practicing the SAT, function notation is very common on there. All right. F of x, g of x, but we know that this is just another way of saying y. All right. But it's a way in which you can kind of distinguish equations. So for number 1, when I say f of 3, what this means is find the value of y when x equals 3. That's what that means. And where would you find that value? Well, you would go to this function, right? That equation. And then the same idea for number 2, but you would use the g equation. All right. For number 3, you'll be multiplying f of x times g of x. But for number 4, this circle is different than this. All right, this means f of g of x, which could also be asked in a different notation. And it means find g of 3. So plug 3 into the g equation. And then whatever you get, you then would plug into f. All right, and the last two I don't give you numbers to plug in. I give you the function to plug in. So remember, take G and then plug it into F. The whole function. So take the entire G of X function, and where you see X in this one, plug it in. And then do the opposite in 6. Take the F of X function and plug it into G. All right. So look, if you have any questions with this page, and this is a skill that we need to all hopefully have by now, is we got to look back at our notes. It's been a week or so since we've done these, but I wanted to just quickly review it because I think when we do take our next quiz, which will be on just a short quiz, which would be on factoring by grouping and factoring sum and difference. Sorry, guys, where'd that go? We will also include some function notation on there as well. So thanks. Sorry if that was a little longer than I anticipated. But guys, enjoy your day. Let me know if you have questions.